Ladies and gentlemen, good afternoonish. What is it? 16:08. I don't know, it's completely pitch black out there. I have a new cold and it's all great here in December. But welcome to Dr. Plurings battery charging adventures. Adventures in battery charging. Previously last time we were doing this stuff, I had these two connected in series. They are still connected in series. It's these two Dell 1100 watt power supplies. I'm a bit congested, sorry, pardon. That's what it is. I had 4 or 5, maybe 4 days when I felt like pretty decent, like I didn't have an infection in my body. But here we are again. Anyway, with this thing and those power supplies in series providing about 25 volts, I was able to push about 10 amperes into the battery, which is down on the floor. So that's something. That's something. 280 watts or something. It came out to. But I feel like it's not quite enough. And I need to clear my head here in a different video, maybe, on all that is going to happen here. For now, we're focusing a little bit on the battery. I managed to get an ESP32 to talk to the battery management system, the JK-BMS, over Bluetooth, and gotten that via ESP Home into Home Assistant. So I have the control of the BMS and status of everything in Home Assistant now, which is excellent. I don't need to use the app there, and I can get to it from wherever I can do other clever things here eventually. And also a very important, quite important safety feature actually, because the first thing that when you power on your BMS and you connect to it in the app here, the first thing it says for you to do, it says that you should do, is change the password now before it's too late, it says. Well, the thing is that it doesn't really matter because the way the protocol works, when this is so stupid, this is Chinese engineering and information security in a nutshell. The way it works is when the client connects, the BMS sends the password to the client, and then it is verified locally in the client against the actual password. So you don't really need a password to manage the BMS. It doesn't matter what you set for a password. You might as well use the standard 1, 2, 3, 4, 5, 6. If you change that password, you will prevent people who only have the app walking around and finding your BMS to connect to it and messing about with your settings maybe. But okay, that's a bit far-fetched, but still it's really poor security to have it that way. It's incredibly stupid design, is what it is. But anyway, the security measure of then having having it this way is that since I constantly now have a Bluetooth client connected to it, it doesn't advertise itself as hello, I'm here, I'm a Bluetooth device, connect to me and do things to me. It doesn't do that, so that's quite good. Now though, for this, because this is so incredibly slow. This is a new device that I just bought. This is my only Android device I own. This rubbish. A 6-year-old iPad beats this in performance, at least how it feels to use. It was cheap, of course, but still. I bet you could get a used iPad with similar performance for a reasonable price. See, I was missing one tool, I thought. What was that? Are you sure you're missing a tool? Yeah, not really. I don't know. In any case, I'm going to disconnect power now to that ESP32 that is connected here via Bluetooth. I have disconnected it now. It should update here pretty soonish and say that I don't see it any longer. Where did you go? Maybe not. It should if this thing would be any. Yeah. So anyway, I've charged the battery completely 2 times and discharged it completely 1 time, and now we're down to 71% state of charge, which would be enough to see how much power we can actually cram into this thing. This was able to do 10 amperes. This I expected to be able to do a bit more. It should, I think. But when are you going to realize that there's nothing there? Maybe you're not. Oh, okay. Well, yeah, it has heavy-duty terminals, but they don't feel very securely tightened down to the board. Oh, I think that we hold on to the connector here whilst doing stuff to it. Should I connect the battery? No. I just connect the meter first here and see what we get, if we get anything at all. Or if we get an explosion. Maybe I should wear my safety goggles for this. Do we have the polarity correct? Actually, yes. Not that it matters for a meter, but anyway. Mate, you should realize that there's nothing there and that your information is old. You usually pull down to update, apparently not. Here. Right, fine, whatever. Open this thing. And yes, allow. Yes, and that's the one I want to connect to. There you go, beep beep. And now we should have the same information, but we should have a bit quicker updating of the information. I want it as close to real time as possible here. And there we have voltage out of this thing, boost converter thing, maybe. It's supposed to be anyway. So I'm now disconnecting my power supplies from the old boost converter. There you go. With my custom-made little connector here. Yeah, it's just a solid core copper wire soldered onto the wires. You take what you have when you're experimenting and prototyping and such. But I see now that the connector here might actually be a little bit on the wide side to actually fit. No, it's going to work. It's going to work, maybe. The polarity, yes, the polarity was actually correct. That's plus. Yeah, that's plus and that's minus. So it should be, there you go. Can we get it a little bit in here? Would be nice. Should have made those a little bit longer there, the copper. So the copper things poking out. But there you go. That's I think that's a secure enough connection. But yeah, I want to be. Yeah, we're here to cram as much power out of this as possible, right? Yes, we are. Okay then. Well, later on, maybe it is a bit too much to have 2 of these in series. Maybe I can get by with 1. And my intention here now is to first test how much power we can get through this with 25 volts on the input, and then turn one of them off and see what we can get with 12.5 volts on the input. Oh, I turn power on to the power supplies. There we go. And they shouldn't do a whole lot. We need to wait for a while. Seems to be a little while. You can't wait just 5 seconds, because then they'll go into protection mode or turn off or something. Can we see the meter there? Kind of 0.24 volts. Okay. Another thing that I want to check just whilst we're here. I'm putting the safety goggles on. Actually, yes. Just in case this is bad or capacitor blows or whatever could happen. I want to say the battery is still connected to this boost converter. Are we getting anything on the output, or rather the input? 0.1 of a volt we're getting. So it's not completely off, and you could probably get current flowing that way if all circumstances are something. Right, so on this we have, this should be a low voltage protection thing. So if this is under a voltage that we set this to, this should turn off. And there we have constant current and constant voltage. Yes, we can now turn on. Let's see here, the fan is connected to the upper power supply, so that's the one we will try and power on first. Here we go, 11.77 volts. Yeah, these are still in series now, even when I'm only running one of them, so the current is going through the other power supply, which can't be good really, and they're turned off for some reason. I waited a while. Okay, let's try it again. I've ran it with only one and it has worked just fine. I don't know what it means really that the current goes through the other one. If that does something, there's probably components involved. There has to be, and there's a voltage drop because the output of the power supply is 12.5 volts and we're seeing 11.8. There's definitely some sort of thing going on. Are we getting a voltage out here too, out of this one? Well, what are you saying? 51 volts? Oh, damn it, that's a bit much. If you can find the thing, there it is. Yes. Which way are you supposed to turn this? You turn it counterclockwise to lower. Yes, you have to go a few turns there. Quite a few turns. You want this at 29.2 or close to thereabouts. You went too far. Okay, there's a lag apparently. Yeah, it would be because there's no load attached, right? Could we have a load? It would be this. Yeah, it would be this thing, and if we want to load on it, maybe I want to load on it here. That isn't the battery, just for safety and so on. This might not be able to take exactly 29 volts, but it should be able to handle. Now we're at 17. That's too low. But if we turn this up to about 24, the light bulbs will be very happy with 24 volts. And then we can see what the current is actually set to, since the voltage was set rather high here from the factory or wherever it came from. I think that we power off whilst doing connections, right? Yeah. Safety first in Dr. Plurings everything, always. That connection is not very good, but it's good enough. Okay, and this wire is a little bit on the short side, and I don't want to ruin my lovely bulbs here and my lovely light fixture. Come on, mate. You would like to go in there, right? You wouldn't you? Yes, you would. And also this one. Here we go. If only the wires would have been a little bit longer on this, but they aren't. So there you go. These are now a little bit close to my face, I feel, but whatever. And I would have to be, that's not good. That just is not good. But what are we going to do? It's a mess already. Yes, maybe something like that. Now the people can see the nice cozy glow from them. Adjust the camera angle a bit, or adjust the camera a bit at least. Here we go, maybe. Camera, are you heating up or about to turn off or something on me again? I don't quite trust this iPhone 13. No. Okay, as I did set it to 24 volts, so if we power on here now, yes, we get light. Amazing. It's quite bright. There, so good. Hot already. Damn it, this is halogen bulbs. Let's see if we can try and limit the current a bit, maybe. Something would happen. I'm not sure, mate. What do we have? 23.8 volts. Maybe you turn it the other way to get the current to be limited. No, there we go. There we go. Very nice. I don't know what the current is currently. I don't know what the current is currently set to, but anyway, that's good enough. Now I know that it is turned down in any case. Right, power it off again and disconnect this here little test load. I only wanted to be sure that the current limiting was engaged. And oh god damn bloody havet! Very hot, I can tell you already. Yes, it is a test load. It's supposed to be draw power. Yes, very hot. Do not touch halogen bulbs that are operating or just have been operated. Oh, very hot indeed. There we go. Now we have current limiting. See if we can adjust the voltage to something. Yeah, maybe I can't really see through these here goggles, and I can't see the other side of this thing either. There we go. 24, 25. 26, 27, 28. And that's good enough to connect the battery, right? 28.2. Yeah, but no, you want to set it to where you want it, because when you connect the battery, the voltage will go down since it will be current limiting. Yes, that is true. Come on, mate. There you go. So we want to set this to what we want it to be, which is a bit sensitive. 29 point. Come on. 28.9. Yeah, 28.9. That's good enough for now. Yes. Do you want to connect the battery now? Yeah, maybe. See here that verify password. Stupid, silly thing. Yeah, so now the app here already knows the password, and it will simply, what do you say, validate my input to something that it already knows. It won't hash it. It should have hashed my input and sent it to the BMS for validation, and it should validate the hash of what I have set the password for, but that's not what it's doing apparently, since the ESP home thing can connect without anything. It just needs the MAC address for the thing. Oh, and it didn't work for some reason. Again. There you go. Charge is apparently on. We turn that off. There you go. Charging is turned off. Status. Yes. We could even turn off discharging, and that should should make it safer to muck about with these here wires, right? Yes, it should. Okay, can turn off the power again. Here you go. And voltage is slowly dropping. Excellent. This connector is not inspiring me with a whole lot. Shut up! I'm using you. What do you? It's telling me that you forgot to turn me off. But no, I did not forget to turn you off. I'm using you for stupid goddamn thing. This. So these wires are connected to the battery, but via the BMS shouldn't really be anything here. Should we check just to be safer, slightly safer anyway. Well, there is 11 point. It's falling. Great. Okay, then unscrew. Someone had tightened that pretty well. Indeed. And this, do you think this connector can really take this torque without you holding on to it? No. Careful. But I'm using you. Knock it off. Just be on, please. There you go. Negative and positive. Positive is, of course, the blue wire. That makes perfect sense. And negative is the yellow and green wire. And that should be... Just to be sure, yes, negative is this one. I'm going to stand up for this and maybe bring you in a little bit. Maybe. Yeah, careful. I don't have the greatest of wire gauges here, so you see what we get, but they should be good at such short runs that we have. 1.5 square millimeters, it should be good for a few amperes. We can see, or we will see. Okay, so yeah, there you go. We'll put this back in this circuit so we can see the voltage and so on. For now, at least we start with looking at the voltage. We're doing this together here. There we go. It's at 0.8 volts. Great. Okay, if we turn on the power supply now, we should see the voltage of the power supply. We can try this first. Turn on discharging, and we should see like 26 volts about. Yes, and a little LED came on this thing. Great, I suppose. Did anything happen there? I didn't. And this is sort of the output here. Output, input, whatever. Yes, okay. So now we turn power on again. Here you go. We have 28, pretty close to 20, as good as 29 volts. Yeah, very close to 29 volts. Enable charging. Yes, this is now the things should start happening here. There, 2.6 amperes into the thing. Excellent. Very good, very safe and easy start. Though not quite so interested in the voltage right now, as I will be in the current coming out of going through. However you want to look at it really. This wire, for example. That's a bit difficult to read there, maybe. Yes, 5 amperes out of the power supply. Great. If we turn the second power supply on, that should go to half. Nothing happened. It should have halved. Why wouldn't it? Oh, I've done something silly here. I have disconnected it from the wall apparently. Some reason, unfathomable reason. Yes. There we go. Overload. Yes, we need to have it there. Oh, it's in the on thing, but it will probably fail. It will go into its fault mode. Right, it has not accepted being in the on position. No, there you go. Okay, turn it off and wait a bit. I turn it off. The second power supply. It's not in shot, mate, what you're talking about. No. And camera was stopped due to temperature. I don't know what this is about. This is silly. That it does this. Well, because I used the torch on it. It is not even that warm, really. Yeah, it is a bit warm, the phone, but it's not hot. A bit too sensitive, maybe. Cheerio. Cheers. I mean. Alright. 6 amperes out of 1 power supply. 11.6 volts, supposedly. About here is actually also where I want to have this thing. This thing should be a low voltage protection or something that turns this off if the voltage goes under something. That I want that just about here. So you see, if we turn this, try and turn this down until it turns off, and then just turn it back up a bit. That was a long ways to go, apparently. Okay, I've not turned this a lot of turns and nothing's happening. No, this is too many turns now. There. Yes. Okay, should we try turning it the other way then? It doesn't seem to do a whole lot that way neither. There it went into under voltage protection. Very good. Okay, just turn it back a little bit till it goes on again. There it is on at 11.6 volts, and just a little bit more, about there. Okay. Now I turned the second power supply on. There we go, 25 volts, 2 power supplies in series. Now it is time to see what we can actually get out of this thing. I would have wanted the fan to blow, you know, straight or something over the heatsink. It has a fan on it, and it supposedly has a temperature thing here that might turn on eventually. I don't know, but I would prefer to actively cool it whilst we go here. I think if we bring it up a little bit, so we can put the fan right there. Yes. Okay, we turn the power off again. There you go. Yes, and then we want to raise this up so we get to about there. Yeah, but then you won't have the fan blowing on the components on this side, the inductor and so on. That's correct. This way it won't be optimally in any way, shape or form. It's a bit... Oh, well, okay, fine. Let me see what we get here. I have changed the fuse on the battery, so it is now a 30 ampere fuse, and I've set the BMS accordingly for its current protection and so on. Yeah, okay, we should return the current up then and see what we can get out of this. We want to be watching here, 2.6 amperes currently. We want to be watching there, amperes out of this and amperes into it. Okay, here we go. This voltage, the difference is not a whole lot. It's like 1.5 volt difference. Can it really do that? Can it work at such low? Apparently. Okay, we're up to 7.5. 11.5. This is a new record for power whilst charging, 330 watts. Yes, we're up to, is that it? Did it click? No, 15 amperes. This is where the old fuse would have blown. 0.5 kilowatt I'm putting into it right now. Almost now, 420 watts. Okay. Maybe a little feel on the, yeah, okay, this wire is heating up a little bit, I believe. Yes, this one too maybe. Okay, so that's about it for this. And you could exchange this for, we take it up a little bit more. Is this thing getting hot or something? No, it's really cool. The heatsink is a little bit warm. It's something around here is warm-ish. It's built-in fan. Well, my fan is blowing straight on the thermistor. I think it's right there, the thermistor. This it's supposed to sense the heat and turn on its built-in fan. That's might be suboptimal. But 17 amperes, we're steady at here right now. We're going a bit further then. Yeah. $20 on the input and 19 on the output. These wires are getting slightly hot. This one is fine. Anything else here that is? This thing is heating up a little bit as it is. 550 watts. Yeah, and it could probably go further, much further. In theory, we have 2 kilowatts here, but that's way over the limit. What was it? This, I think that this was rated for 40 amperes on the input, but it is fused for 60 for some reason. Yeah, sure. So we should be at half capacity, but these are Chinese ratings, and that usually means that half capacity of what they have rated it for is where it will comfortably work, if it works at all. Yeah, that's good. If I were to turn one of the power supplies off right now, we would this would double and we would go to 40 amperes. And I want to see what we can get with only one power supply. So I'm going to back this off again. 0.5 kilowatt. That's decent enough. I want to back this off to something. Well, we saw that 20 amperes seemed to be fine. So if we take this down to 10 or thereabouts on the input, and then turn one of the power supplies off, like so, it went to 23.23.5 amperes on the input and 10 on the output. Is it like stable and nice on the output? It keeps that 10.1. Yes, it does. There you go, 24 amperes. Question is just what this does. Since it is passing through the other power supply, there must be a diode or something that drops about it drops about 1 volt, and we are pulling 23 amperes, so that is also then 23 watts that must be dissipated in this power supply in some way, shape or form. Problem is just that's not a lot for these things, but the fan it's off, so the fan, I don't think the fan is active on it. Maybe no, the LED shows a fault. And is the fan on? Can I check that with something that isn't like a very short screwdriver? Maybe this. No. Well, the fan is further in. Okay, my sense of smell is not the greatest at the moment, but I can smell hot electronics. The inductor is cool, the heatsink is not very hot, but something is suboptimal to have a cold and be very congested whilst doing stuff like this. I would really like to be able to localize where that smell is coming from. But here we are. We're now charging it with 10 amperes, 270 watts for one power supply. Really, to do this properly, I will have to desolder the wires and only get one power supply on to really see what this does or can do. I suppose we turn this up a bit and see what happens. And we trust that this power supply won't, the one that is off, that won't burn. Or do silly things, right? $25 amperes. Is this wire is alright? Yes, it is. Now the fan on the thing here is starting to spin. And the little light has come on there. Was that on previously? I don't know. Does it say anything that that's with an LED? Not anything that is legible or could be interpreted to what it's actually doing. The temperatures seem to be fine. Or is it the fan? Could be the fan in the power supply that started to spin. But this one, I don't know. I think that this one is spinning too. No. That's not doing anything. So it's the fan in the power supply that came on. But only one of them, and the air coming out of it is not cold, I can tell you. You see how much power we're pulling from the wall and how efficient this is, if it is efficient. There is some loss here in the second power supply. Maybe we should just do this without it if you want to see how far you can take this, really. Maybe. Okay, you want to go to this thing? No. Yes, I want to go to this thing and this thing. And there, we're pulling. Let's come off. Would you focus? Focus. There you go. 338 watts from the wall and 322 into the battery. Okay, someone is off here because it cannot be that efficient. Well, yes, it can. 50 watts of loss. I don't think that's too unreasonable. With this setup, do we get? Does it feel like we're getting 50 watts out here? Maybe. It's pretty warm, the air coming out of the power supply. That's nice. Or nice, but it's at least the fan controller in this thing is working, which is excellent news. It means that we should be able to push it. It should be. I'm trusting these power supplies to go up to 96 amperes or whatever it says on them, because it's really good stuff. Right. Push it a bit further. Sure, mate. .30 amperes. Okay. It doesn't really seem to want to go higher than so. Yes, there it goes. 34. There it went down to 31. Okay, now it's starting to get a little bit unreliable. Could be the under voltage protection, maybe, that is doing stuff. Yes, it is. Adjust that a little bit to 11.5. We're getting out here. It's good, right? Yeah, it's good. But these 50 watts are going somewhere, and okay, yeah, the lower power supply is definitely getting really warm here in a spot. I'm not liking it. If we turn it on, it should be... there you go. That's what the fan controller in it thinks of its current state. Right. Nice. Oh, the funny smell is coming out of it too. Very nice. That's we lost a bit of power there. It might have broken. Something might have broken. Okay, I'm going to let it cool off here now. What is going on? Yes, that's, yeah, funny smell. The funny smell is definitely coming out of the second power supply there, which was off during this thing, and has some sort of component in this circuit, which is dropping 1 volt and therefore dissipating 31 watts. That's 30 watts of all the 50. I'm all over the place, I know this, but we had about 50 watts of loss from the wall to the battery, and if 30 of that was dumped into the second power supply for no good reason really, then that should mean that we actually only had a loss of like 30 watts. I sort of lost my train of thought there, but something thereabouts. That is extremely good, if that's the case. Should we can turn charging off maybe? Or what is the safest way of turning this off now? I'm not sure, mate. If you turn the charging off, the load will go away completely. There we go. Now have absolutely no load. But this will be fine. We have cooled down now. You can throttle down here, please, if you wouldn't mind. I suppose you would. Okay, you can still turn it off that way. There, something. Oh, I think that this needs a Norwegian reset. I pulled the power. full power, wait a moment, and then plug it back in. There. Yes. For how long? A little while longer. I imagine. A little while longer. That was not a good smell that came out of the second power supply. That was not a good idea to run that much current through it without it being part of the circuit. I think it was completely fine when they were in series, but when they are still in series and you only have one of them powered, that's not recommended. Put it that way. Really not recommended, apparently. Okay, let's see here if we has it been a while? Close. For a while it's been. Yeah, we turn them on again. Okay, are things normal? Does the second power supply work? The one that wasn't part of this? Nah. Not really, mate. I think it's dead. It's showing. It's showing a green LED. Funny enough. Okay. Well, why aren't you working then? This one is working right. This one is working fine. What about you? I don't want to. Okay, we may have burned something there. This one went into fault mode. The other one is showing green. Shut up! I'm using you. What do you push here to just say that I'm still interested in your services? There you go. Okay, the upper one is showing fault. The lower one is showing green. It should mean that it's on, but no voltage there. But if we measure only this power supply, then there and there, nothing. Okay, I destroyed the power supply. Fucking hell, that's not good. I would have wanted to use this, maybe. Yeah, I didn't want to destroy it. Really, I did something. Again. I don't know what to tell you. The fan thinks that I need to cool down as much as possible. I think the air coming out of it isn't really that hot anymore. However, that smell was something that might have burnt in it. Yeah. I suppose. What color is the LED? It's yellow. If we turn it on, it's green. This is so strange that it would be green. What's this? It doesn't do anything with that one. Yellow, on, green, yes, but no voltage. Okay then. Right, so what did we learn? To summarize, that you should not have these in series without using both of them. That's really stupid, because the fan won't spin up and therefore something will heat up too much in it and it will destroy itself. Quite probably destroy itself, which might have been what has happened here. Might be what has happened here. So I need to change I need to desolder and solder onto only this power supply, which should still be healthy. And then I'll be able to get up to I don't know what is comfortable, but maybe 30 amperes out of one through this thing. This can deliver 90, no problem at all. Just the only problem is that it will be quite loud, but this might be able to push like 35 through it or something. Yeah, and then what? 35 amperes at 12.5 volts. What is that? Calculator, please. Here, calculator. There you go. 35 amperes at 12.5. That's 37.5 watts. And we should be able to do it with only one power supply. Oh, pardon me. That's about the limit of the wiring here. Yes. And yeah, half a kilowatt. Half a kilowatt battery is 4 kilowatt hours, so about 8 hours to charge it fully from nothing to fully charged. About. That's a bit. I mean, it's fine usually, but maybe sometimes you would like to be able to really push as much current in as quickly as possible, and for that I really would need 2 power supplies in series here to do that. 35 amperes here is still 35 amperes, but at 25 volts you can simply double this number, then we're up to 875 watts. That's almost a kilowatt, and then we're down to 4.5 hours maybe. Yes, but apparently it's not possible to have them in series here, so like so, and then maybe only use one of them or something. I really need to clear my mind on all things that is going through here, but this was maybe it for now. I seem to have destroyed a power supply, even through my congested nose here. I could smell that was not a healthy electronic smell, put it that way. That's a shame, really. Yes. But there you go, ladies and gentlemen. I suppose. I think so, really, mate, because that's about it. I've destroyed it. Maybe the Norwegian reset did not help, really, or I've not let it rest for enough time. But I think I broke it. It was really hot. You heard the fan; it went to maximum when I turned it on. Oh, so there you go. Yes, ladies and gentlemen, thank you so very much for watching Dr. Plurings Battery Laboratorium and Power Supply Destroying. Yes, I said, next installment might well be trying to clear my mind of everything that is going to go in the system as a whole in the caravan, whilst not going into too much detail on every single bit, but so to actually be able to get the whole thing out of my head. There's too much there are too many things going on right now in there. There you are. Thank you so very much for watching. Cheerio.